Now see next question number 5 from exercise 2.1. Find the equations of the normals to the curve 3x square minus y square equals to 8 which are parallel to the line x plus 3y equals to 4. So in previous example, first we find equation of tangents because we get slope from the given curve after differentiating the given curve with respect to x, that is slope of tangent. So from that we find the equation of tangent, then we find the slope of normal and then find equation of normal. Here we have to find equation of normals and condition is which are parallel to the line, that means the required normals are parallel to this line x plus 3y equals to 4. So write in solution, given curve is 3x square minus y square equals to 8. Differentiate with respect to x. So derivative of 3x square we get 6x minus derivative of y square we get 2y into dy by dx is equals to derivative of 8 which is constant is 0. So right here, therefore minus 2y into dy by dx is equals to minus 6x. We transfer this 6x to right hand side. So minus minus get cancelled and we divide this 6 by 2, we get 3. So right here, therefore dy by dx is equals to 3 into x by y. Now we require slope of normal. This is slope of tangent. So right here, therefore slope of tangent is 3x by y. Now we require slope of tangent at a point where we have to find the equation of normals. So we consider here point, let p of x1 y1 be any point on the curve. Therefore slope of tangent at p is, so we write here dy by dx at p is equals to, we write this x as x1, y as y1, so write here 3x1 upon y1 as the slope of tangent. Now we find slope of normal from this slope of tangent. We know that normal is perpendicular to the tangent. Therefore slope of normal is, we take reciprocal of it, so write minus y1 upon x1 and this 3 which is in numerator, so we write in denominator, so write minus 1 by 3 into y by x. Now here this given line is parallel to the normal, so we find slope of this line. Therefore slope of line x plus 3y is equals to 4 is, we compare this with ax plus by is equals to c. So we get here slope as f is equals to minus a by b. So here a is 1, that is coefficient of x is 1. So right here minus 1 upon value of b is 3. So minus 1 by 3. So slope of this given line is minus 1 by 3 and we calculate slope of normal which is minus 1 by 3 into y by x. Now normal and line are parallel, therefore these slopes are equal. Therefore we write here, since normal and line are parallel, therefore minus 1 by 3 y1 upon x1 is equals to minus 1 by 3. So 3 get cancelled, minus minus sign get cancelled, we get here y1 is equals to x1. So we denote this as equation number 1. Now see here, this point P of x1 y1 lies on the curve. That means this point must satisfy the equation of curve. So we write here, since P of x1 y1 lies on the curve 3x square minus y square equals to 8. Therefore, we write here 3x1 square minus y1 square equals to 8. And now from equation 1, we have x1 equals to y1. So write this x1 as y1 or y1 as x1. So we write here 3 into, we write this x1 as y1. So write here y1 square minus y1 square is equals to 8. So 3 times y1 square minus 2 times y1 square, we get 2 times y1 square is equals to 8. So here y1 square equals to 4. That means y1 is equals to plus or minus 2. Now we write from this equation 1, x1 is equals to plus or minus 2. So the points are 2, 2, minus 2, minus 2. Now we have to find the equation of normal at point 2, 2 and minus 2, minus 2. So this point you can also represent as P and this point as Q. So we find equation of normal at point P, then we find equation of normal at Q. So right here, therefore, equation of normal at P having slope. Now here, slope of normal is minus 1 by 3. So here we write a slope as minus 1 by 3 and coordinate of point P are 2, 2. So x1 equals to 2, y1 equals to 2. So by using slope point form, we write here y minus y1 is equals to m in bracket x minus x1 for our convenience, and then replace the value of x1, y1. Here y1 is 2. So right here y minus 2 is equal to m, slope is minus 1 by 3. So minus 1 by 3 into x minus x1, x1 is 2. So transfer this 3 to left hand side, we get 3y minus 6 is equal to, so right hand side multiply by minus 1, so we get minus x minus minus plus 2. Transfer both these terms of right hand side to left hand side, we get plus x plus 3y. After transferring 2 to left hand side, we get minus 2. Minus 6 minus 2, we get minus 8 equals to 0. This is first equation of normal at P. Now we find equation of normal, therefore equation of normal at Q having slope minus 1 by 3. Therefore y minus 2. Now see here, we have to take y here coordinate of point Q. So here x1 is minus 2, y1 is minus 2. So minus minus get plus. So y plus 2 is equals to minus 1 by 3 in bracket x plus 2. So transfer this 3 to left hand side. So we get 3y plus 6 is equals to minus x minus 2. Transfer both terms of RHS to left hand side. So right here plus x plus 3y plus 6. After transferring this minus 2 to left hand side, we get plus. So we write here plus 8 equals to 0. Now if you observe the equations, we get the equations x plus 3y minus 8 equals to 0, and here x plus 3y plus 8 equals to 0. That means these two terms are same, and this minus 8 changes to plus 8. Now see next question, question 6. If the line y equals to 4x minus 5 touches the curve y square equals to ax cube plus b at the point 2, 3, find a and b. So first we draw a rough sketch. Here given line touches the curve. So suppose this line touches this curve and this line touch at point 2, 3. That means this line is tangent to this given curve. So we use that concept. So write in solution, the given equation of curve is y square equals to ax cube plus b. So differentiate with respect to x. Therefore, we get derivative of y square as 2y into dy by dx, and derivative of ax cube, that is 3a into x square, and b is a single constant, so its derivative is 0. So write dy by dx here. Therefore, dy by dx is equal to 3a x square upon 2y. Now this is the slope of tangent. We require slope of tangent at 2, 3. So we write here at p of 2, 3. Therefore, dy by dx at p is equal to, so we replace this x by 2 and y by 3. So write here 3 into a into value of x is 2. So write 2 square upon 2 into y, value of y is 3. So these 3 get cancelled, 1 2 get cancelled. So right here dy by dx at p is equal to 2a. Now this is slope of tangent, and we have provided that the line is touching. That means this line is also tangent to that curve. So we find slope of this given line. Therefore, slope of line y equals to 4x minus 5 is, first we write this in general form. So we write, or you can compare this with y equals to mx plus c. So from this we write m is equals to 4. So directly write here slope of line y equals to 4x minus 5 is 4. Now this line touching this curve, so this line is a tangent. So slope of this line, and we find the slope of a line from this given equation and from the curve. So these two slopes are equal. So we write here, therefore twice a equals to 4. So we get a is equals to 2. Now this point p of 2, 3 lies on this curve. That means this point must satisfy the equation of curve. So we write here, since p of 2, 3 lies on the curve, therefore lies on the curve, write the equation of curve, y square is equal to ax cube plus b. Therefore y is 3, so write 3 square is equal to a into x is 2, so write 2 cube plus b. So 3 square is equal to, we replace the value of a by 2, so we get here 2 into 2 cube, 2 cube is 8, or you can write here 3 square also direct, that is 9 plus b. So we get here 8 to the 16 plus b. So we transfer this 16 to left hand side, we get here 9 minus 16 is equals to b. That means b is equals to, here we get minus 7. So here a equals to 2, b equals to minus 7, and we have to find in this problem value of a and b. So right here, therefore a is equals to 2 and b is equals to minus 7. Now say question number 7. A particle moves along a curve 6y equals to x cube plus 2. Find the points on the curve at which y coordinate is changing 8 times as fast as x coordinate. So here what change is used, that means we have to differentiate given function with respect to time. So here we familiar with definition velocity and acceleration. We know that if x is displacement, when this function x differentiate with respect to t, we get here dx by dt, which is velocity, and when we differentiate this dx by dt or v with respect to t, we get here d2x by dt square, that is d by dt of v. So rate of change of velocity we call acceleration. So here you always remember, when word changing is given or a rate is given, that means we have to differentiate that function with respect to time. So see here in solution, a particle moves along a curve. So given equation of curve is 6y equals to x cube plus 2. So right here in solution, given curve is 6y is equal to x cube plus 2. Find the points on the curve. We have to find the points on the curve. So we consider here points. So right here, let p of x1, y1 be any point on the curve. So this point must satisfy this equation. So we write here, therefore 6y1 is equal to x1 cube plus 2. So denote this as equation number first. Now see here, find the points on the curve at which the y coordinate is changing 8 times as fast as x coordinate. So here what changing is used, that means we have to differentiate given function with respect to time. So we differentiate this equation 1 with respect to t, differentiate with respect to t. So we get here 6y1. So we differentiate this y1 by t. So write dy1 by dt is equals to, here x1 we differentiate with respect to t. So write here 3x1 square into dx1 by dt, and 2 is single constant, so its derivative is 0. So write here 6 dy1 by dt is equal to 3x1 square into dx1 by dt. Now here condition is given, y coordinate is changing 8 times as fast as x coordinate, and we consider here coordinate x1 and y1. So see here, according to given condition we write, so denote this as equation number second. According to given condition, y coordinate is changing, that means we have to write dy1 by dt, and which is 8 times change in x coordinate. So we write here dx1 by dt. So we use this condition and substitute value dy1 by dt or dx1 by dt in equation number second. So right here, therefore from equation second 6 times we replace this dy1 by dt by 8 times dx1 by dt. So 8 into dx1 by dt is equals to 3x1 square dx1 by dt. So this we write in this way also, dx1 by dt get cancelled with dx1 by dt. This 3 to the we get 6. So 2 into 8 we get 16 is equals to x1 square, that means x1 is equals to plus or minus 4. Now we get value of x coordinate, we have to find value of y coordinate. So for that we have to substitute this x1 equals to plus 4 in equation 1 and x1 equals to minus 4 in equation 1. We get y1 coordinate. So right here, when x1 is equals to plus 4, from equation first we write here 6y1 is equals to, we write this x1 by 4. So we get here plus 4 cube plus 2, 4 cube we get 64, 64 plus 2 we get 66. So 6y1 is equals to 66, that means y1 is equals to 11. Therefore first coordinate we consider as p of 4, 11. Now we have to find second coordinate. So we write here when x1 equals to minus 4. So in place of 4 we have to write minus 4. So write here from equation 1 6y1 is equals to minus 4 cube plus 2. So minus 4 cube we get minus 64 because here power is odd. So write minus 64 plus 2. That means here we get minus 62. So 6y1 is equals to minus 62. That is y1 is equals to minus 62 upon 6. So we divide here both numerator and denominator by 2. So here we get minus 31 by 3. So when x1 equals to minus 4, we get y1 equals to minus 31 by 3. Therefore this coordinate we consider q. Therefore q is minus 4 minus 31 by 3. Therefore the points on the curve are, therefore the points on the curve are Q of 4, 11, Q of minus 4 minus 31 by 3. So in this way you have to solve the question.